dealing with section F1 in your book. F for option F. So, talking about food. It is an item that we deliberately take into our mouths and swallow. And it's going to depend based on where you are, what is appropriately labeled food. Because some things we might not be used to that they're used to in different countries. It can be either natural or artificial. A lot of what we're eating on a daily basis is artificial or at least partially artificial. Ideally, the foods that we are eating contain one or more nutrients. There are 6 nutrients, or 6 classes of nutrients. And what they are components of food used by our bodies to provide energy or for the growth or repair of tissues. We have 3 major nutrients. Those are lipids, carbohydrates, and proteins. Have you talked about those in bio yet?
Yeah.
Excellent. It's going to be a nice, easy unit. The minor nutrients are vitamins and minerals. And we also consider water as a nutrient. So one of those 6 nutrients that we need, it's water. It's essential because all of those biochemical processes that are taking place in our body aren't going to happen if there's not water present. Another key word for us is malnourishment. That's when we are lacking nutrients. We can also have malnutrition, and that means we either have too much or too little of a specific nutrient. So malnutrition, either too little or too much of a nutrient. And if you're lacking all 6 of those nutrients, you are it's called undernutrition. Undernutrition if you're lacking all 6 of them, and can lead to starvation. So undernutrition, you're missing all 6 of those nutrients. You're not getting enough of a single one of them. We're going to watch 2 quick videos today, and our first one is coming up next. And it is from a movie called Idiocracy.
Rondo's got a place great. It's got electrolytes.
So wait a minute. What you're saying is that you want us to put water on the crops?
Yes.
Water. Like out the toilet?
I mean, it doesn't have to be out of the toilet, but yeah, that's the idea. But Rondo's got what plants crave.
It's got electrolytes.
Okay, look. The plants aren't growing, so I'm pretty sure that the Rondo's not working. Now, I'm no botanist, but I do know that if you put water on plants, they grow.
Well, I've never seen no plants growing in no toilet.
Well, that's good. You sure you ain't the smartest guy in the room? Okay, look. You want to solve this problem. I want to get my garden, so why don't we just try it, okay? And not worry about what plants crave.
Rondo's got what plants crave. Yeah, it's got electrolytes.
What are electrolytes? Do you even know? It's what they used to make Rondo. Yeah, but why do they use them to make Rondo?
Okay. Sometimes ads that we hear have just that much lovely reasoning in them as to why you should have a specific food in your diet. What are electrolytes?
They destroy free radicals.
They do. They can destroy free radicals. Good. Yeah, but they could. They're salts. So they were watering with salt water. Not a smart thing to do. They had very salty land, and so they started watering, and it was all good after that. But just remember, got to pay attention to what they're actually advertising and if it's any good for us. So, lipids are fats and oils. Fats and oils we know are insoluble in water or other polar substances. They're insoluble in water. It's always a good thing to remember. It's like taking vegetable oil and putting it in with water. You can shake it up and it gets little globules, but it always separates back out because it's not dissolving in water. Lipids work as an energy source. They help construct cell membranes. They also regulate body temperature. They're a good energy source for us because it's more concentrated energy than carbohydrates. I'll tell you why in a second. Okay, we've done a lot with oxidation and reduction reactions. And we know that carbohydrates have oxygens on them. Lipids have some, but not as many. And so they don't have as many pre-oxidized areas. They have more places where we can oxidize. So it's going to release more energy and produce more carbon dioxide and water. So that's why it's a better energy source than carbohydrates are. It's got more places to react. Okay, lipids are esters of glycerol, which is propan 1,2,3-triol, and 3 fatty acids. And those are long-chain carboxylic acids. So again, if you don't remember those functional groups, if you just memorize them for the test, rememorize them. Get them in your head. You see all those dots there. If those dots mean that all 3 of those are the same length, then we call it a simple glyceride. If all of them have the same number of carbons and hydrogens, it's a simple glyceride. If they have different lengths, they're called mixed glycerides. Again, if they're all the same length, it's a simple glyceride. If they're different lengths, they're mixed glycerides. Lipids may either be saturated, unsaturated, or polyunsaturated. We've heard those words before in organic chemistry. Saturated means there's no double bonds. When we're talking about saturated lipids, we're generally dealing with animal lipids. So butters, things that are coming from animals are generally saturated. And they are going to be solid at room temperature. So saturated are going to be solid at room temperature, no double bonds, and often animal in origin. Unsaturated and polyunsaturated mean we either have one or multiple double bonds. Those are often from fish and plants. And they are liquid at room temperature. So olive oil, vegetable oil. And how long the carbon chain is and the amount of saturation is going to determine those chemical and physical properties like we were just discussing. So saturated, solid at room temperature, unsaturated, polyunsaturated, liquid at room temperature. Okay, let's take a look at this one. I want to know, is this A, saturated, B, unsaturated, C, polyunsaturated? A, saturated, B, unsaturated, C, polyunsaturated. Oops, hang on. Go back. Okay, I need 2 more of you. Oh, there we go. Now we're all in. And this one. And the majority of you are saying unsaturated. I would agree. There is a single carbon-carbon double bond. It's unsaturated. If we had multiples of these double-double bonds between the carbons, then we would have polyunsaturated. Okay, I've got another question for you. Would this be a simple A or mixed B glyceride? Simple or mixed? Cool, we are all in now. I would agree with those of you that said simple because they have the same number of carbons as we're going through. Could also say mixed because it has less hydrogens. I would agree with both of them. Never mind. I'm going with both. Okay, carbohydrates. And we're going to go back to each of these classes of nutrients and talk about their chemical reactivity later. But right now we're getting the overview. So the general empirical formula is CH2O, or more general, we get, if the Moby starts working here, CmH2ON. It's our general empirical formula. They are a great energy source and also are used for some cell construction. And you probably know this already, but they're coming from, back. They're coming from grains, fruits, vegetables. And we know that, each of these things are formed by photosynthesis. So if we have a monosaccharide, they follow that formula CH2ON, where N is greater than 2. They are most simple of the carbohydrates. They contain 1 carbonyl group, C double bond O, and at least 2 hydroxyl groups, OHs. So really we've either got an aldehyde or a ketone when we're dealing with these. An aldehyde or a ketone. And some examples of monosaccharides are glucose, fructose, and ribose. Okay, disaccharides are condensation of two monosaccharides. Condensation means that we're going to get a different product out as well, and that product is water. We're condensing water out of it. Examples: maltose, lactose, and sucrose. Just to name some of the most predominant. If we had a polysaccharide, that means we've got a bunch of them together. It's a condensation polymer. So add that polysaccharides are condensation polymers. Bless you.
They're what?
Condensation polymers. Bless you.
Polysaccharide.
Yep. And examples are starch and cellulose. Okay, then we've got our proteins. Those are polymers of amino acids. We know amines are dealing with nitrogens. We have nitrogens attached here. An amino acid is a molecule containing an amine group, carboxylic acid group, and a side chain. And it's really essential to get these amino acids into our body because our body doesn't create them on its own. So it's essential that we're getting proteins in our diet. Proteins will and must contain carbon, hydrogen, oxygen, and nitrogen, but they may also contain phosphorus and or sulfur. Okay, sometimes proteins are used for protein biosynthesis. Bless you. Can be used to used and converted to glucose, so an energy source. Other ways of producing energy, and it's our main dietary source of nitrogen. So we have an amino acid here, and when it becomes a polymer of an amino acid, so protein, what it does is it undergoes a condensation reaction. Another one of them undergoing condensation. And it's going to lose one of the nitrogens from the amino group and the hydroxyl group from the carboxylic acid. So those produce my water. It's my byproduct. And then I get a polymer of the rest of the stuff. A few more seconds. I see a bunch of pens still. Another brief video.